Okay, so now at this point we have extensively covered the theory behind how we're going to be implementing gravity and jumping. So in this video, we're just going to get our gravity implemented, and then once that's finished, we'll take a look at implementing our jump.
Right. So let's get started. Let's create some public fields to get started with. So we've got a public float. Now we're going to have to hold a value for gravity. So our very first field is going to be gravity. We're going to default this to a float of 21. Set up a second float. This one will be our terminal velocity. We'll set it to a default value of 20F. We will also need to save another property. This one will be a public float called vertical velocity. And I will set its getter and setter. That should put that together. Now let's go ahead and skeleton in our gravity. So we'll make it return void. Call this method apply gravity. It's not going to take any values. Let's bracket it in. Now the very first thing it has to do is make sure that we're not exceeding our terminal velocity. So we'll say if our move vector.y is greater than negative terminal velocity, then apply gravity. To apply gravity, what we're going to do is set move vector equal to a new vector 3. We're going to take in its current x and z because we don't want to mess with that, and we're going to put that back. So move vector dot x. I'm going to put 0 in for now. We'll come back and change this. That's the y component. And move vector dot z.
Okay.
So we're going to leave those in place. Now our calculation stuff has to take place where our y component is. So what we're going to do is we're going to take our existing move vector dot y and we're going to subtract gravity times our delta time.
So literally turning gravity into meters per second calculation.
Correct.
A downward meters per second calculation.
Exactly. Now the second part of this is we need to check to see if our TP controller, that character controller field that we've saved in here, the reference to our character controller, is grounded. So if it is grounded, then we know we're on the ground. We want to check to make sure that our move vector dot y is less than -1. So basically we're saying if we're grounded and move y is less than -1, we want to set it to -1. We don't want to have a runaway gravity situation. So this is going to keep our gravity in check. Now it's pretty much the same thing again. We're going to take our move vector and we're going to set it to a new vector. So I'm going to copy all that. But instead of recalculating out our move vector y,
it'll just be -1.
We'll just set it to -1.
Yeah.
That's it. So that's apply gravity. Now up here inside of process motion to get it working, when we initially did this in the last video, I brought out the multiply move vector by delta time to convert our move vector into a speed per second. Now because of the way gravity works and it's a cascading effect, we're constantly applying it, we don't want to shrink our move vector and record it because that will throw off our calculations for gravity. So we're going to basically take our delta time here. We still need to apply it. We still need to do the conversion, but I'm going to apply it at the very end here, just before we feed it into our move.
Okay.
We're not going to save the results of this because that would throw our calculations off. So now that we're doing this here, I'm going to delete this part of our
basically we no longer need to do that.
Exactly. We just did it for clarification process. Now we don't need it.
Right.
But what we do need to do is to reapply our vertical velocity to our move vector dot y. So to do that, we will once again borrow our move vector assignment here and paste that in place. And instead of setting it to -1, we're going to set it to our vertical velocity.
Makes sense.
After that, we need to apply gravity.
Right. Now, at this point, we haven't saved out what our vertical velocity is.
Not yet.
We'll handle that over in TP Controller
Yep.
in a moment.
Yep, we'll do that in a sec. So we're going to apply gravity. To apply gravity, we just call the apply gravity method.
Which is ready to rock now.
Right. So right now, everything as far as the TP motor is concerned to enforce gravity is in place.
Mm-hmm.
We're still missing the one component, which is what you're mentioning. We
Right.
have to save our vertical component before we zero it out.
Right.
Otherwise, we'll just be repeating the same part of gravity.
Well, we get no acceleration.
Right.
And our gravity would probably be very slow.
Yep. So to fix that, we're going to call TP motor. We're going to get its instance, which once again is just a reference to the instance that we created.
Mm-hmm.
We're going to take its terminal velocity, our vertical velocity, and we're going to set it to equal the TP motor dot instance dot move vector, and we're going to grab its y component. This is going to save out the y component of move vector into vertical velocity. Once it gets saved out, it's going to zero out our move vector, do our initial calculations, come back from get locomotion input, call the motor's update. Motor update is going to get called. It's going to snap the align character if we're moving and process motion.
Mm-hmm.
Now, part of process motion is to come up here and do all the old stuff that it used to do.
But now it'll reapply that vertical velocity back into the Y.
Right. And then once that has been reapplied, it's going to apply gravity.
Just like we said it should work.
Right. So we're going to build this out, see if there's any errors. No errors. We're going to jump back into Unity. I've got my character up in the air just to test this.
Mm-hmm.
So we'll give it a sec. It doesn't look like there's any errors. Let's go ahead and play, and our character falls.
Yep.
We can also verify by running over to our ramp, run up our ramp, run off, and our character falls.
And there's a nice little drop off at the bottom.
Mm-hmm.
Nice acceleration.
So now we know gravity works.
Mm-hmm.
So we
Can we
jump.
change our value and test it?
Sure.
Just since we're right here.
Mm-hmm. Well, I'll leave them up in the air just so we can test it. So do you want more gravity or less gravity?
Less gravity.
Less gravity.
Let's just see what happens.
All right,
Set it to something really low, like 5.
All right, 5. All right. We hit play, and it's slower. Now we can do the reverse. Let's take gravity, and we'll put it up to crazy high, like 50.
Sure.
But we're going to take our terminal velocity.
And set it to like 5?
Yeah, and we'll set it to 5.
So now we should never be dragged down faster than 5.
So we hit play. We accelerate really quick, but we hit terminal velocity.
And that's it.
And that's it.
So yeah, they both seem to be working great.
So if I set terminal velocity to, say, 50, just so we match, and I hit play, we should start out slow, but we rapidly accelerate until we slam into the ground.
Nice. So that gets our basic gravity system implemented. We're going to go ahead and end the video here. And in the next video, we're going to go through the implementation process of our jump ability, which, as we discussed in the theory video, we're going to be breaking up over TP controller and TP motor just so that we have future expandability for allowing the jump to do more than just cause the character to fly up in the air. The jump can also queue up an animation. Also, we're going to be opening up the door for more actions than just jump. We could end up having use, or if you wanted to expand it into anything else, such as punch, kick, or reload your weapon, whatever. All of that would be extensible through the system we're going to establish.
Right.
So that will wrap things up for this video. Thank you for watching.